Good morning, Townview. Welcome back to Chemistry Online.
A configuration is just an arrangement. And when we talk about electron configuration, we're talking about the arrangement of electrons. And what you're going to find out today is that basically they all have a specific place where they go. All right, let's move on. So real quick, I want everyone to draw a periodic table. Here's what yours is going to look like. You're going to make a line straight down. You're going to come out this way just like that. And then you're going to go this way. And then we're going to go up. And then we're going to come out like that. And then we do like this. And that is your periodic table. The straighter your lines, the better. And then right underneath, we're going to put our lanthanides and our actinides just like that. And if your paper is this big, your periodic table should be about that big. Not half the page, but like, relatively large, because we're gonna label stuff. All right, I'm gonna give you all a minute and then we'll go over it. All right, so let's go ahead and label these real quick. Helium over to this side on my periodic table. You don't need to do the same thing, but my helium is gonna be right here. So this block, this is the first block we're gonna talk about today. This is called the S block. This first period on the S block, we call this this is period 1. We call this 1s1. So every element in this group is going to have an electron configuration that goes in 1. So this is 1s1. All the ones in the second group are going to be s2. So this is going to be 1s2. Now if we move to the next period, period 2, this is going to be 2s1. This is going to be 2s2. In period 3, this is going to be 3s1. This is going to be 3s2. So here's period 4, 5, 6, and 7. We're not going to label all of these. But in period 7, what's this one going to be called? 7s1. What about this one? 7s2. All right, let's go ahead and move to our next block. So the next block we're going to discuss is this one right here. And this one is called the P block. So we're ignoring helium. Helium is not a part of the P block. Helium is a part of the S block. So what period does the P block start in? It starts in period 2. So this first one is going to be 2p1. So this is also 1, that's 2, 3, 4, 5, and 6. So this is going to be 2p1. What about the next one? What's that going to be? 2p2, the next one, 2p3, next one, 2p4, and then the next one, and then the last one, 2p6. So if the next period is 3p, so this is 3p1, what's this last one going to be? 3p6. What about the one below it? That's going to be 4p6. And what about the next one? 5p6. And the last one? 6p6. So what do all the noble gases end in? They all end in p6. All right, let's keep going. So this is our next block. And this one is called the D block. So most students miss questions because of the D block. So the D block starts in period 4. However, its energy level is the third energy level. So 21 actually starts with, so this is going to be 4s1, this is 4s2. Over here, we're at 3d1. So even though it's in the fourth period, it's the third energy level. So we have to go down an energy level. This is going to be 3d2, 3d3, all the way to 3d10. So how many electrons can we fit for every period on the D block? How many electrons can we fit? We can fit 10. All right, so the last group we're going to talk about is this one down here. And this last group is the F block. So what period is the F block in? So take a look at my periodic table. Here's the F block. Where does it start at? So it starts in period 6. However, this is the fourth energy level. And then this is the fifth energy level. So this is going to be 4F1 all the way to 4F14. And then down here we have 5F1 all the way to 5F14. So how many electrons can we fit in the F block? So there's 14 per row. All right, so the most confusing part of this whole thing is when we write our configurations, you're going to go from 4s2 to 3d10 and then to 4p1 or 4p6 or whatever it is you're going from here. So here's how I like to remember them. Which one did we learn about first? Which block? All right, where does the S block start in? It starts in the first period. Second one we talked about was the P block. Where does it start? Which one was the third one we talked about? And where does it start? And then the last one we talked about, and that's how you remember them. So the S block starts with 1, the P block starts with 2, the D block starts with 3, and the F block starts with 4. So when you look at the periodic table, look up here. So here's the beginning of the D block. What energy level is this? 3. This is 3D all the way to 3D10. This is 4D, and this is 5D down here. Any questions on the blocks? You don't need to write all this down. As we work through it, you'll get a good understanding of it. You don't need to fill this out though. All right, let's move on. So this is the same chart that you guys just saw, except this one is completely filled out. You don't need to fill this out. Just wanted to show it to you. All right, don't worry about this. All right, so we're just gonna write down some stuff. So the S sublevel, that's the S block that we were just talking about. The S sublevel can hold how many electrons? It holds 2 electrons. Can we figure that out by looking at the periodic table? How do we know? How do we know this only holds 2 electrons? All right, so there are only 2 groups in the S block. And this is 1, this is 2. So we know it can only hold 2 electrons. The S block only has 1 orbital. So what is an orbital? When we talk about planets, an orbital is basically the orbit. So this is the sun, and this is the Earth. And that's the path that the Earth takes around the sun. That's an orbit. When we say orbital with regard to electrons, we're talking about the path that the electrons can take. And 1 orbital can hold 2 electrons. And you'll see that pattern continues as we move forward. So for every orbital, you're going to have 2 electrons. They're just going to be spinning in opposite directions. So you'll have one going clockwise, one going counterclockwise. So the S sublevel, it can hold 2 electrons, and it has 1 orbital. And I also want to talk about the shape. So the S block is spherical. All right, the next block we talked about, that's the P block. This can hold a total of 6 electrons. If you look at the periodic table, can you see the 6 electrons? Yes, you can. So if you look at the P block, it's got a total of 6 groups. These are the 6 electrons. How many orbitals in the P block? There's a total of 3 orbitals. I'm about to show them to you in a minute. All right, so let's take a look at these, see what they actually look like. So here's your S block. So this is 1s, 2s, 3s. They're all just perfectly spherical. And how many electrons do they hold? 2. One is moving clockwise, and then another one is moving counterclockwise. And again, this is a sphere, not a circle. So you can imagine these 2 electrons anywhere. They're just moving in opposite directions. And usually they're as far from each other as they can be because they repel each other, because they're both negatively charged. Here's the P block. So the P block is dumbbell shaped. So right now where you wrote P block, I want you to write the shape for the P block. The P block is dumbbell shaped. Really, it's figure 8 shaped, but we call that dumbbell shaped. And here you can see the 3 orbitals. So there's one right there. There's another one. And that's our 3rd orbital. Is this an electron? Are you looking at electrons? What are you looking at? What are they if they're not electrons? They're not protons. They're not neutrons. Nope.
No.
Nope.
Mitochondria.
All right, so what are orbitals? Let's go back to our planetary example. So here's the sun, and then here's the orbit. So what is the orbit? It's the path that the Earth can take. So in the case of these orbitals right here, what are they? It's empty space that the electrons can occupy. Now, there are 3 orbitals in the P block. So there's another one right there. And when we combine the 3, what do they look like? What shape do they take when we combine all of them? They look spherical. But basically, you're looking at 3 different orbitals here. So there's the blue one, the green one, the red one. And this is all empty space that different electrons can occupy. All right? And that's the dumbbell shape right there. Here's what it actually looks like when we look at an actual atom. So here's the S block. So the first electrons that we fill, the first electrons are going to go here. Why do the first electrons go here? Why do they want to be in the 1s? What's in the center? The nucleus. Where do the electrons want to be? They want to be as close to the nucleus as possible. So this is the first space that they occupy. After they fill 1s, where do they go? They go to 2s, which is kind of farther out, but that's where they go next. After 2s is occupied, where do they go? Well, they go to 2p because there is no 1p. So they go to 2p, one goes here, another one goes here, another one goes here, then one goes here, another one goes here, and then another one goes here. And now the whole thing is filled. So it ends in 2p6, and that's going to be neon. So if you look at the periodic table, neon is right there, and it's got electrons in all of its orbitals. So that's 2p6 right there. All right, so here there's nothing to write. I just wanted to show it to you. So this is what the D sublevel looks like. How many orbitals in the D sublevel? There are 5. And the shape, you don't need to write the shape. Just know that this is a complex shape. And when you combine all of them, what shape do they make up? They kind of look spherical. They also look like those nerd candies. You know those nerd candies? Nerd clusters, that's right. All right, let's move on. Here's the F block. The F block is also very complex. How many orbitals in the F block? There's a total of 7, and when we combine them, it looks even more like a nerd's cluster. All right, let's move on. All right, so we already wrote all this stuff down. Next to P sublevel, I want you to write dumbbell. That's going to be the shape of the P. And then for D, and both of those are complex. You don't really need to write a shape for them. Just know that they hold 10 electrons. So the D sublevel holds 10 electrons, and they all sit in 5 orbitals. The F sublevel, that's going to hold 14 electrons, and they sit in 7 orbitals. All right, let's move on. So now we're going to talk about some rules with electron configuration. Let's write these out one at a time. So the first one is going to be Aufbau's principle. Aufbau's principle tells us that electrons, they fill the lowest energy level first. Don't worry about the second part. So Aufbau's principle tells us that electrons are going to fill the lowest energy level first. So when I was taught about Aufbau's principle, I was just shown this chart. And I was told to write the chart down. And here's how the chart works. So if we look at the S block, where does the S block start? Period 1. So we start from 1, we go all the way down to 7, and that's going to be our S block. Where does the P block start? It starts in period 2, so we start the P block in period 2. Where does the D block start? So we start writing it in 3, and where does the F block start? 4, and there's only 2 of them, so there's 4 and 5. So we write it out, and basically electrons are just going to start filling the top first. So Aufbau's principle tells us electrons are going to fill the lowest energy level first. So let's imagine that we were at a DaBaby concert. Who here likes DaBaby? All right, cool, a lot of y'all. All right, DaBaby's dope. All right, so we're at a DaBaby concert, and you bought those tickets that say you can take any seat you want as long as it's not occupied. And you're DaBaby's biggest fan. So you get to this concert, where are you going to go sit? All right, you're going to sit in 1S first. Once 1S is filled, where are you going to sit? After 2S is filled, where are you going to sit? After 2P is filled, where are you going to sit? After 3S, after 3P, after 4S. So basically, this is the order that we fill things. That's what Gauss principle is all about. But you can actually look at the periodic table and figure this stuff out. And I'll show you how to do that in a minute. So next rule we're going to write down is Pauli's exclusion principle. So Pauli's exclusion principle tells us that an orbit, we already talked about this, but an orbit can hold how many electrons? It can hold 2 electrons, but they have to have opposite spins. So you're going to have one going clockwise, one going counterclockwise. So Pauli's exclusion principle, it tells you that an orbital can hold 2 electrons, and they're going to have opposite spins. All right, so here's our last rule. This is called Hund's rule. And Hund's rule tells us that within a sublevel, you're going to place 1 electron per orbital before pairing them up. Go ahead and write that down, and then we'll discuss. All right, so let's discuss Hund's rule. So the way I typically explain this one is the bus rule. So let's say that you got on the bus, and you were the first person on the bus. Here's the bus driver. You were the first person on the bus, and then you sit here. And then some random person comes in after you, and they sit right here. Is that okay? Why not? It's a free country. It's a free bus. You're not paying for it. Well, people are usually parking close to the door, but that's not what's going on in the bus. So what's wrong with this person? Why is it not okay that they sit next to you? All right, exactly. So what does Hund's rule tell us? It tells us that there needs to be a person sitting at every seat before you ever even consider sitting next to me. You know what I'm talking about? Once all the seats are filled, at that point, you can come and sit next to me. So Hund's rule tells us that when we're filling these orbitals in orbital notation, we have to have an electron in each orbital before they begin doubling up. So this will not work. This is okay. Now, looking at this example right here, this is a multiple choice example. How many electrons do you see? So the electrons are the arrows. How many electrons are in each one of these? What is it? How many? All right, so there's 2 in each box. How many total in this whole thing? All right, 7. So this represents nitrogen. That's what you're looking at here. So if I ask you for the orbital notation for nitrogen, which one is correct? A or B? Why? What's wrong with A? All right, so they double filled this box before filling this box. So that's what's wrong with this one. You're going to see this on the test very soon. So our common assessment is on the 8th week. Right now, we're finishing up the 6th week, right? So not next week, but the following week, you're going to take your CA. And this question is on your CA. So let's move on. Orbital notation, we're going to talk about this next class. We're going to talk about how to fill this. Today, though, I want to focus on electron configuration. So we're going to jump straight here, and we're going to do these electron configurations. All right, so let's go ahead and do our first electron configuration. So here's hydrogen. We're going to start with hydrogen. So look at my periodic table. Everybody look up here. So what's the electron configuration for hydrogen? 1, what? 1s1 is correct. 1s1. What about helium? What's the electron configuration for helium? 1s2. What about lithium? All right, so 2s1 is correct, but anytime we write an electron configuration, we're going to write the configuration for the elements that come before it too. So for lithium, it's actually 1s2, 2s1. Okay? Let's go ahead and get the next one. Next one is beryllium. So what's beryllium going to be? 1s2, 2s2. What about boron? All right, what does it start with? It's going to start from the very top. It always starts from the top. So 1s2, then what? 2s2, and then after 2s2, 2p1. So the p block starts with a 2. That's why it's 2p1. Let's do carbon, and then we'll discuss a little bit more. So what does carbon start with? 1s2, 2s2, 2p what? 2p2. So let's count up our electrons. How many should hydrogen have? It should have 1. There it is. How many should helium have? There it is. How many should lithium have? So there's 2 plus 1, so that's a total of 3. What about beryllium? It should have 4. There they are. What about boron? How many should it have? And there they are. And then carbon, and there they are. All right, so we just did the easy ones. Let's go ahead and work some tough ones. All right, so we're going to do the electron configuration for sulfur. Okay? So it's the same thing. And for those of you who aren't following along, I want everybody to grab a periodic table. All right, everybody grab your periodic table. And then look at mine for a second. We just start. This is what we're doing. We're starting from the top. We filled 1s2. After 1s2 is filled, where do we go next? We go to 2s, and then we fill it. And then we go to 2p, and then we fill it. And then we go to 3s and fill it. And then 3p. And then 4s. We're basically filling them in order. Y'all remember Aufbau's chart? Let me show y'all Aufbau's chart. All right, so here's Aufbau's chart. And what does the order look like? It looks just like your periodic table. So look at your periodic table. We're starting with 1s, which Aufbau's chart tells you is the first thing. After 1s, where do we go? 2s. After 2s, where do we go? After 2p, where do we go? 3s. After 3s. So it's the chart, it just follows the periodic table. After 4s, where do we go? 3 what? 3d. After 3d, where do we go? 4p. So if you follow the periodic table, you don't need Aufbau's chart. So let's go ahead and let's work out our example. And to do sulfur, we need a total of 16 electrons. So until we have 16 electrons, we're going to fill all of the shells. So let's go ahead and start from the top. Where does sulfur start? 1s2, then what? 2s2, then what? 2 what? 2p what? Why 2p6? How many electrons do we have so far? So far we have 10. This is 10 right here. 2 plus 2 plus 6 is 10. How many do we need? So we're going to fill all the shells until we get to 16. So what comes after 2p? So look at my periodic table. After 2p, this is 2p, we just filled it. Where do we go next? 3s. How many do we put in 3s? After 3s2, where do we go? This is, what is this? 3 what? 3p. So this is 3p1, 3p2, 3p3, 3p4. And then we stop at 3p4. So let's count our electrons. So here we have 10. So the first 3, if you fill them completely, they always have 10. And then here we have 6, so that's the total of 16 electrons. Let's do argon. Where does it start? 1s2, 2s2, what is it? 2p6, then what? 3s2, 3p6. All right, so the first 3, when you fill them, they equal 10. And then this is 8, argon has 18. So that's the total number of electrons we need. Let's go ahead and let's do bromine. So you see how these are in chronological order? 1 to 18. So every element has the complete configuration of the one before it. So earlier we were talking about my name and how my name has my dad's name and my grandpa's name and my great-grandpa's name. That's basically how this goes too. I didn't make the rules. So argon has the complete configuration of everything before it. And when we talk about 1s, we don't need to say 1s1 because 1s2 includes 1s1. And 2s2 also includes 2s1. And 2p6 includes everything in the p block. But anyway, let's keep going. So bromine, where does it start? 1s2, then what? 2s2, 2p6, 3s2. All right, so look at your periodic table. We just did 3s2. What comes after 3s? 3p. And if we fill 3p, it's going to get us to 18 electrons. We need 35, which means we're going to completely fill this one. So what's it going to be? 3p6, then what? And then after 4s, what comes immediately after 4s? 3d10, good. 3d10 is going to put us right here at zinc. And then after zinc, we just need to go to bromine, which is at 5. So what's this one? That's 4p1, 2, 3, 4, 5. So 4p5. And if we count our electrons, the first 3, if they're filled, those are 10. The second 3, if they're filled, those are 10. The third one by itself is 10. and then that's 5, so that's a total of 35, which is what we needed. All right, let's keep going. Let's do lead. That's PB. All right, so PB is number 82. Yeah. But these questions, most of the time, the problems that students get wrong is they'll confuse. Like, you'll see what I'm talking about when we fill the, I'll just fix it in this one. So the first thing you're going to notice, what they're going to do for you to get this one wrong is, everybody looking at my screen, look over here real quick. What they'll do is they'll swap this 3 out with a 4. There will be one answer choice with a 3, one answer choice with a 4. So which one do you think students usually pick? The one with the 4, because it looks like it makes more sense. But you just got to remember that the D block always starts with 3. So the first D block you should see should be the 3. All right, let's move on. So PB, how many electrons does it have? 82. So this is the first one that's going to include all of the blocks. So let's go ahead, start from the top. What's our first one? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. So at 4p6, we just got to what? We just got to krypton. So we're at 36 so far. We still need to go to lead. So let's go ahead, keep going. After 4p6, where do we go? 5s2, 4d10, good. After 4d10, we just got to cadmium. What comes next? 5p6, 6s2, nope. So take a look here at 6. What comes after 6s? What is this? What is it? 4 what? 4f what? 14. We need to fill it because this has 71 and we're going all the way to 82. So this is going to be 4f14. After 4f14, now where are we at? 5d what? 5d10, and now we're at mercury. And then what? All right, 6p what? 6p2. So one way we could figure out what the correct answer is we can count all these electrons. How many electrons should we count here? Well, so that's 10, 20, 30. Here's 38 plus 10, that's 48. Plus 2 is 50, and then plus 6 is 56. Plus 14, where are we at now? 56 plus 14, what is that? 70, and then 80, and then 82. So you can either be asked, you could be given an element, asked for the configuration, or you could be given a configuration, asked for the element. It's very easy to go from configuration to element. The way you do that, there are 2 ways. You can either count up all your electrons. We just counted the electrons. It gave us 82. We look at the periodic table. 82 is lead. So you could count your electrons. Another thing you could do is just look at the last part of the configuration. So 6p2. We go to our periodic table. Everybody look at mine. That's 2p, 3p, 4p, 5p, 6p. 6p1, 6p2, we're at lead. So either one of those methods will get you to the correct answer. Any questions on this? No? All right, so what y'all just learned is called the longhand. Are y'all ready for shorthand? Are you sure? Y'all don't want no more longhand? Are you sure? All right, so let's go ahead and do the shorthand for lead. So PB, except this time we're doing shorthand. So when you're doing shorthand, here's lead right here. When you're doing shorthand, everybody look at my periodic table. I want to make sure you see this. Are we looking? All right, so when we do shorthand, we're going to find the nearest noble gas, but it has to be before it. We can't use radon because lead doesn't have all the electrons that radon has. But lead does have all the electrons that xenon has. So what we're going to do is we're going to put xenon in brackets. So xenon in bracket, close the bracket, and this is 54 of our electrons. And now we just got to write out the remaining electrons. So after xenon, where do we go? Six S2, then where do we go? 4F14, then what? 5D10, 6P2. So basically, y'all remember how we talked earlier about all of the noble gases? They end in P6. So everything that comes after this P6, so you see this 5P6? Everything that comes after this P6 is included in our electron configuration. Now, if we add 54 to 2 to 14 to 10 to 2, what do we get? You're going to get 82. So even if you're looking at shorthand, counting the electrons will get you to the correct answer. Any questions on this? When we're working these problems out, yes. All right, let's keep going. So let's do shorthand for sulfur. Here's sulfur right here. Everybody look at my periodic table, sulfur. Which noble gas are we going to use for sulfur? We're going to use neon in bracket, and that eats up 10 of our electrons. We have 6 left. Where do we go after neon? 3s2, then what? 3p what? 3p4. So everything after the 2p6, 3s2, and 3p4 are still included in our shorthand configuration. 10 plus 2 plus 4, that gives us the 16 electrons that we wanted. Any questions on this? Do we feel okay about it? All right, let's go ahead and do some practice.
If you don't know how to do chemistry, hit that subscribe button. Let's go!